Now, welcome back to the part 2 of this lecture number 25. So, in the last part you have seen different kinds of important aspects of deep learning and features. Deep learning features mean not feature, but different aspects of deep learning. But we need to talk about different models and architecture of deep learning, right. So, in a general we divide these models in two parts. One is based on shallow network, other one is based on the deep neural networks. Remember, everything is neural network here, okay, in deep learning. Whether using a shallow network or a deep network, that will determine complexity of your network. So, shallow means you have only one hidden layer. You go back to ANN, which I taught you, some time back. That is what I taught you, so that you can understand these things very well. And basically, you have an input layer, which is providing the data, and then you have one hidden layer only. And as you know, data are basically processed in a different way, and then you have output. In comparison, deep neural networks have many hidden layers. That is why I have written n. N can be anything, it can be 100, thousands also, depending on your computational power and abilities to handle data. You can have as many as hidden layer possible. So, this is a parallel processing technique, as you know, like a human brain, and therefore, you can have, if each layer is taking the input from the previous layer and providing the input to the next layer. So, layer 1 takes input from layer 0 and provides the output as input. Whatever output will come from layer 1 will be input to layer 2, and that is how things goes on. So, as you have more and more layers, the complexity of calculation will increase, nothing else. That is why the learning takes a lot of time in deep learning methods. It takes extremely large number of times for deep learning methods, and this is the main aspects of deep learning things. You have to keep in mind these aspects. And so, when normally n is greater than 2 is quite good model, but it can be even more than that. We also present a typical deep learning networks contains many hidden layers, and it can be even 10, 15, 20, 30, 40, hundreds also. But output layers and input layers are fixed. One output layer, one input layer. That is what the final and initial. Okay, then you can put as many as layers possible. So, what are the different techniques? Here we divide these techniques based on supervised, unsupervised, and hybrid learning. Hybrid is mixture of these two. Okay, supervised is also called as a discriminative learning, and unsupervised is also called as generative learning. That is okay, forget about it. Supervised and unsupervised is quite okay. So, in case of supervised learning, you can have MLP, multi-layer perception model, then CNN, convolutional neural network, reinforcement neural network, and there are many parts of that, LSTM, bi-LSTM, GRU. We will talk about it later, some of these. And for unsupervised learning, you can have GN. GN stands for, I think A stands for, let me see, I also forget. GN stands for generative adaptive network, sorry, generative adversarial network, that is called GN. And then you can have auto encoders, then you can have SOM, which is nothing but what is SOM? Self organizing map, self organizing maps. Okay. Then you have DBN, okay, that is nothing but deep transfer, deep, what is called deep something, I also forget some of this time, we will get back to you little later. And then you have a hybrid learning like mixture, CNN, LSTM, GNN, CNN, AE, SVM, DTL. DTL stands for the very easy deep transfer learning. Okay. So, this is basically the different techniques possible. But remember, we cannot use all of this for material science, and many of these are actually cannot be used even because of the problems. But hybrids are very useful. If you can use both of them together. Normally, the techniques which you widely use are MLP, GN, CNN, and RN. These are the ones which you use most widely. But unsupervised learning techniques can also be used in DL, like AE, auto encoder, or SOM can be also used for this purpose. So, these are the different techniques possible in this process. So, we are going to talk about a little bit of ANN, because that is the basic thing of the deep learning. And we have already talked about it, that deep learning methods work the way human brain works, and human brain is what? It is a parallel processing system. Why is it a parallel processing system? Because it has billions of neurons, and neurons are actually connected to each other. One neuron connected to another neuron, connected to another neuron, connected to another neuron. Okay. So, you can give an input here, and these neurons will parallelly process the data. So, basically what? Input will be taken by this neuron, process it and give an output. This output will be input to this neuron, and this will go on. Finally, you will get an output, final output. That is what happens. So, initial input is processed many times, and how it is processed, that is what we are trying to learn in neural network. Very simple. A typical element is processing element is a neuron, and it has a lot of dendrites. You see, these dendrites actually are capturing the data. So, if you put something hot on your screen, it can sense it very easily, right. So, these dendrites collect the data, and then this data are fed to the nucleus. Nucleus processes the data. Nucleus is the powerhouse, and it then output of this data are passed through the action, and using the synaptic synapses, this is fed to the next neuron. So, there is another neuron. So, similarly, another dendrites, lot of these dendrites connected. Then you have a cell body. This is cell body in the nucleus, and this cell body is then form axon, and from axon again it will form the synapses. Okay. So, that is what it is. So, this output of this one is fed to the input of the next neuron. So, that is why it is called a parallel processing technique. It is parallelly processing this. One output is fed to the next one as input, process, and then again similar thing happens. So, human brains has massive capability, you cannot even imagine. Its ability to identify patterns with all kinds of astonishingly high degree of accuracy. That is the idea. We want to mimic that human brain using deep learning techniques. And so artificial neural networks are basically based on that structure of human brain, and that is why we are trying to understand how human brain works. Doctors, scientists, they are trying hard to understand how a human brain works, and that is still a mystery, let me tell you. And because it is a very complex architecture, although we know the basic units, but how does it work, still not that. Since these techniques that like MLP, multilayer perception model, are based on this human brain or network in the human brain, that is what we need to understand the brain. So, let us talk about P. What stands for P? P is nothing but a perceptron, right. Perceptron is what is a simple binary classification algorithm. Basically, that is what it is, a binary classification which can provide only 0 and 1, and this was first came from Frank Rosenblatt from Cornell, USA, and it is basically nothing but it model using a concept known for essential unit of human brain. It is a hot or cold, it is binary, right. When you are putting a hand inside a refrigerator, it is cold. When you are putting a hand on an oven, it is hot. So, this is a binary, either hot or cold, there is nothing else in between. Well, things are there in between, something which is comfortable to your hand. So, this is what it does, and it has uncanny ability to learn and solve complex problem. So, it can take few inputs, each of which has a weights that we are going to talk now, to signify how important those weights of those inputs, and generate an output which is 0 or 1, that is a binary. However, it can actually combine with our perceptrons as we have seen. So, therefore, in principle it can answer any questions if you have enough sufficient large number of training data and computational power. That is what the dream actually. It will be able to solve any kind of complex problems in the world. You do not need any science, anything, it can solve everything, provided you have a huge data and huge computational power. Well, that is not true actually, provided you understand how our brain works, because that is something which is still missing, although we know that this is how it works, but God knows. Therefore, neuron is basically typical processing unit. It receives input from other neurons and then it processes the data, and once the input is exceeded critical level, it will discharge. That is the electrical pulse, but forget about it. It basically works as a neurotransmitters. They are chemicals which are released from first neuron to the second neuron. That is how the data are transferred. So, if I have to put it together, how this ANN work, what is basically important is that you have a input data, which is nothing but input, as you can see, and then you are putting some weights on the input data. So, basically you multiply the weights with the input data, and the value of the weight will depends upon which input is more important than others. So, then you get this y0 is w0 x0, y1 is w1 x1, yn is wn xn. Then what you do? Then you process. These data are fed to your nucleus, then you process this data. That is what you see, it is showing summation of something. After you process data, you can actually use activation function. This activation functions actually transform the data. There can be various kinds of activation functions possible, which we will talk about in subsequent lectures. So, that this is the basic aspects, this is the whole processing unit. Once the data are multiplied by weights, sum it over, then we apply activation functions on those summed over data, and this activation functions will provide an output. Remember, this output is input to the next neuron, which will do the same way whatever you have done here. That is why those hidden layers are. Hidden layers are going to process your data in the same way what is shown here in this left side of this picture. So, for a single neuron, this is what happened: x1, x2, x3, x10, x5, w1, w2, w3, w5, summation unit, then the transfer activation functions, then you get output. And this can be shown very nicely here, much better. This picture I like it. So, you have inputs, along with you have bias also. I have not talked about bias in the earlier slides. Bias tells you how your data is spread. Okay, this is just like a noise to the data. It is just a noise to data, and if the noise is very large, it will automatically remove or cancel the noise. But sometimes noise, small noise of the data are useful to filter out the data. And then you put weights, sum it over the weights and multiply these weights and the data input, and add also bias, and then you do activation functions. So, this part is very easy for you to understand. You have inputs and bias, weights are multiply the inputs and they are sum it over, and then you add bias also to the data, you get this summation. And then what is still not clear to you, what are the activation functions, how do they perform, that we will discuss in the subsequent lectures also. Finally, it gives you an output. So, this is again shown you same way here, you see it is shown in mathematical form. These are the weights, sum it over, and then you have a activation functions. This is the transfer function, activation function. So, what are these functions, what they do, what are they actually different mathematical functions. You can select them depending on your problem type. So, I will not talk much about this. So, now the question is that's one single perceptrons do. So, you can have a multiple perceptrons, that is what is called a multilayer perceptron, MLP, and it is a network formed by teaming up of perceptrons with additional ones stacked in several layers, and the several layers are basically used to solve complex problems. So, each perceptron in the first layer on the left side, that is the input, and this input is send output to the other perceptron in the second layer, and so on. So, then second layer perceptrons will send the output to the next layer and goes on. That is what it is done. I am telling again and again these facts because many times you will not be able to understand it very clearly, and each layer has can have large number of perceptrons, okay, many large perceptrons, and there are multiple layers present. So, basically you have a n by n matrix type of layers. Here you are showing a 3 layer perceptrons, input, one hidden layer on output. So, what are the difference between normal neural network and these perceptron based neural networks? Remember, MLP is widely used in deep learning, but normal networks, neural network can be used in machine learning. So, main difference between them is that in a classical perceptrons, decision functions are step functions and the output is a binary. On the other hand, neural networks, the activation functions which can be used, there are different kinds of activation function used, and may not be only step functions, and outputs can vary. It may not be only 0 and 1, it can be -1 plus 1 also. So, therefore, this allows you to for probability based predictions or classifications actually. Many of these probability predictions can be done very easily. How does it works? Let us do that. First step, it takes input is x1 I have shown you, multiply them weights. Why does it multiply? Weights allow the perceptron to evaluate a relative importance of each of these inputs. You can have different kinds of weights, one is 0.1, other one is 10, third one may be 0.05, right. So, depending on the importance, relative importance of these variables, or variables are what? As you said, in DL you do not have to manually tell you the features will automatically clear, automatically understood by from the data. So, therefore, the importance of these features can only be evaluated by putting these weights, different amount of weights to it. And neural network algorithms learn by discovering better and better weights that result in more accurate predictions. Okay. So, several algorithms can be used to fine tune these weights, and most important one is back propagation. From the word itself we can understand, initially I may put some weights. Suppose I do not know which variable is more important, which feature is more important, I can put any weights or I can put equal weights to everything. Then I can calculate the output and see whether my output is in line with my prediction. If it is not, then I go back and change the weights again. This is what is called back propagation. You come back and change the weights again and do the back propagation. This is very simple. And you also add some bias. This is a number 1 multiplied by weights. It is not multiplied by weights, it is simply a bias B. This is a technical step that makes it possible to move the activation functions which we will talk about it, activation function up and down, left and right on the curve, so that it can predict your behavior properly. It basically allows you to fine tune the weights, basically that is what it does, the bias. And what are the activation functions? Activation functions map the input values to the required output values, and very different kinds of activation functions allowed. Exponential functions are very common. Exponential functions, or 1 by minus m lambda plus 1, 1 by exponential function plus 1 is very common. This is the one which is one of these activation functions widely used. There are many actually. One can use trigonometrical activation functions also, and especially they are nonlinear in nature. That is what makes them, these networks, more complex. They are not linear, and then it provides you output, and perceptron output is basically classification decision, and in multilayer output of one layer is input to the other layer, therefore it is very important, and in final predictions of the model. As you have seen that there are different kinds of aspects required to have a best MLP, and these actually, one is back propagation, second one is hyperparameter tuning. You can tune these parameters or weights in a different way, and some other advanced techniques structures can be also used. I talked about these aspects in previous lectures also. We will discuss much of these. Backpropagations are very simple. It basically allows you to perform backward passes. In football you have a forward pass and backward pass. This is a backward pass which helps you to tune these weights, and basically nothing but the iterative backward passes. It goes and change the weights and come back and see what is the output. If the output is fine, then it stops the back calculations. If it is not fine, then it again does the same thing, change the weights again and do the calculations. But how do you change the weights? That is what is the, then weights can be changed in a negative way, a positive way. It can be decreased or increased depending on the output, and that is what it does. It is not very difficult to understand, by the way. So, I will just simply want to say one few important aspects of this. At the end, there are many other techniques which you need to discuss other than this ANN, artificial neural network. We need to also discuss about CNN, the convolution neural network. We also need to discuss about recurrent neural networks and variants, generative adversarial networks, this is V not P, autoencoders, colonial map or self organized maps, SOM, I talked about it, deep belief networks or DBN, hybrid drift neural network, HDNN, deep transfer learning, deep reinforcement learning. There are many techniques possible. Obviously, in the time frame I cannot discuss all of these. Some of these I will discuss, like I will discuss about CNN, I will discuss about RNN, some part of GNN and encoder maps if possible. I will discuss also DTL and DBN. Let me see how much time I can get and how much I can discuss, but these are all important for material science aspects. That is what you should need to know. So, let us stop here for the lecture number 25. The next lecture some of these techniques we will discuss. Thank you.